For the last talk of this session on the politics and economy of synthetic biology, we will have David Gruel speaking. And David is an amazing character, actually. David is originally from California, got a degree from Harvard in economics, then went to Yale and got a law degree. Now he's back at Harvard getting a PhD in the social science. He's an Elliott Fellow at Harvard. At the same time as doing all of this, though, he's actually managed to write a book called Network Power, The Social Dynamics of Globalization. This book is an intriguing one, and it discusses some topics which he's going to tell us a little bit about in a couple of minutes, how public-private partnerships work, and how cooperative competition has played a role in economic growth. Now, cooperative competition sounds like an oxymoron to me, but I'm sure we're going to hear from David how this whole thing works. David is also on the board of the BioBricks Foundation, where he provides help in coordinates the legal and public policy aspects of BioBricks. I'm sure you're all going to be wondering, mostly, is how David ever manages to sleep. So David, Gruel, please.
Well, thanks, Reg. For the last 24 hours, I haven't slept, having come out from Boston yesterday, so you'll excuse me if I act like it's 4 a.m. First, I want to thank the Hong Kong University of Science and Technology, too. It's been, as someone who's never been to the university before, it's just a stunning place, and everyone has been so warm and so welcoming. You've done a terrific job, so thank you, guys. And also thanks, of course, to the BBF and to the organizer of the conference. It's been really fun. I know we're near time. I just want to touch on two brief points that I think might help tie together some of the insights that we've heard from Mr. Tsang and Mr. Wadsworth, which is that the dynamics in high-tech innovation in other fields may provide a bit of a lens for how we think synthetic biology may develop. And there are two specific things I want to touch on that Reg touched on one of them just a moment ago. The first is what we might call public-private partnerships, and the second is cooperative competition. So I'll argue that in every field of high technology innovation in which standardization plays a big role, both of these dynamics will be present. So first, on public-private partnerships. This is basically the way in which states help support companies, often through universities, to get areas of technology into the commercial sphere. It involves high levels of research and development, often through tax exemptions and grants, direct investment and help with commercialization, and setting the rules of the game through smart industrial policy. So let me give a few examples of how this works from semiconductor fabrication. So everyone knows that semiconductor fab plants are very costly things to build. So how do they get built? They usually get built through combinations of private and public funds. AMD built a plant in Germany in 2004. It was a $2.4 billion plant in Dresden. The German government covered 2/3 of it, $1.5 billion as a direct investment. STM Electronics put a semiconductor fab plant in Catania, Italy. Italy paid 26% of the $2 billion cost, which was the most it was allowed to pay based on EC regulations. In IBM recently, in East Fishkill, New York, the latest big fab plant in the States went up $2.5 billion. The New York State government put $500 million into the project. These are very big numbers, and I think what the point here is that to get private investment on a scale necessary for certain kinds of high-tech innovation, you often need public investment too, that the two go together. So I think QB3 also provides an example of a public-private partnership where the state of California, through the universities, is trying to pull off something very special in the Bay Area. The second area I think you see in all successful high technology developments is what we might call cooperative competition. So this is the dynamic by which companies cooperate in an upstream phase by setting standards, maintaining technology platforms, and pooling research and development money, and then they compete in downstream markets for products and services. So why is this important? Well, you get a richer ecology of companies than proprietary control of a platform might provide. Let me provide an example of this here, again from semiconductors. Sematech is a semiconductor industry consortium that some of you probably heard of. It was formed in 1987, 14 US-based semiconductor firms and the US government got together And they bring in members from the companies, and they work together to set common technology and infrastructure needs. They identify those needs, they pool resources and leverage risk in order to meet those needs. And then once everybody has figured out the basic hurdles, once everyone through a basic hurdle, the companies go back into their own corners of the ring, so to speak, and compete like crazy in the market. And this seems to work in case after case. You get cooperation in an early phase of production, and then competition in a downstream phase. Another example of this comes, of course, from computer hardware. It's a good example. Lots of different standard setting happens where industry consortia get together, they cooperate in the standardization process, and they compete in downstream products. So, for example, the USB flash drives that a lot of people have, those are compatible in all kinds of hardware products from different companies because there's a deliberate effort to keep those standards open and shared. In software, by contrast, we see a division between proprietary software, that's to say where one company or a group of companies controls a proprietary standard, where you don't get cooperative competition, and I think what has been happening in open source software production, where you even have examples of companies as big as IBM that are putting a lot of energy into building an open platform that they give away because they know that they're going to compete in downstream products. So again, I think the key to cooperative competition is you need to maintain an open platform for users. And this can be achieved by public policy, public-private partnerships, or in some cases by special legal hooks, as I think we'll discuss in the legal session on Sunday morning. But the point for synthetic biology is that I think it has many features in common at this point with both semiconductor fabrication and open source production. It's somewhere in between in terms of capitalization requirements. But even in a very high capitalized industry like semiconductors, you're going to have cooperative competition and public-private partnerships to pull it off, just the same as in areas where standards unite a more networked and decentralized production sphere, as with open source production. So I think that the needs are clear to develop public-private partnerships. I was delighted to hear Mr. Sang's comments on how much Hong Kong is doing. I think that is absolutely terrific and exactly the right direction. And I think that another side of that would be to get these public-private partnerships to support open platforms so that you have a rich ecology of businesses on top of that. So that's what I wanted to say. Thank you very much again for your attention.